Greetings. In this presentation, we will go through the exemplar questions in the chemistry thermodynamics, class 11, chapter 6, chemistry thermodynamics. Okay. Before going through the question, I will show you some important information in this chapter. Mm, so these are the important information. Q refers to heat, W work, delta U is the internal energy change, delta H enthalpy change, delta S entropy change, delta G means Gibbs free energy. Internal energy change delta U is represented equal to Q plus W, that is heat plus work, and heat equal to P external and volume final minus volume initial. Okay, this is for the irreversible isothermal process, and for this Q equal to 2.303 NRT log V final by V initial for a reversible process, and delta H equal to delta U plus delta NGRT. Delta Ng is number of moles of the product minus reactants. And the delta Rg, that is reaction enthalpy, is equal to sum of the enthalpy of the products minus reactants as per the HESS law, and the reaction enthalpy for the gaseous state is bond enthalpy of the reactants, here reactants minus products. Okay, then delta G, that is gives free energy equal to delta H minus T delta S, T temperature and delta S entropy change. Okay, and then it is related to the equilibrium constants delta G equal to minus RT ln K. Okay, now the second information, lattice energy means the energy lattice enthalpy is changing from gas to solid. Okay, and elements changes from gaseous to solid state, that is enthalpy, lattice enthalpy. Ionization enthalpy, that is we are removing electron from the element. Okay, bond enthalpy, there is energy required to break the bond. Example, in the fluorine F2 AFF bond we are breaking. And sublimation, solid to gas. Okay, okay, so thermodynamics is not concerned about energy changes involved in the chemical reaction. It is concerned about the energy changes, the extent to which a chemical reaction proceeds. This is also is details by the thermodynamic chapter. The rate at which the reaction proceeds, and this is not covered in the thermodynamics chapter. The feasibility of a chemical reaction, this is also covered in the thermodynamics. So the option 3 is the correct answer. Second question, which of the following statement is correct? Okay, the presence of the reacting species in a covered beaker is an example of the open system. This is related to the open system and closed system, that is given in your book. Okay, see, open system, there is a exchange of energy as well as matter with the surrounding. Okay, there is a exchange of energy and matter between system and the surrounding. In the closed system, there is no exchange of matter, but the exchange of energy is possible. This is given in the diagram. See here, this is an open system. Here, matter and energy is exchanged, as shown in the diagram. But in a closed system, only energy is exchanged, no matter is exchanged. In the isolated system, nothing is exchanged. Matter is not exchanged, energy is also not exchanged. Okay, this is given here. So this is what is given in this various option. There is an exchange of energy as well as matter between the system and surrounding a closed system. No, this is also wrong. The presence of reactants in a closed vessel made up of a copper is an example of a closed system. Okay, this statement is a correct one. The presence of the reactions in a thermoflask or any other closed, this is a insulated system, though this is not a closed system. Okay, the answer 3 is the option 3 is the correct answer. The state of a gas can be described by quoting the relationship between, okay, that is given in the pressure, volume, temperature and amount. This is given 3. Okay. We can describe the state of a gas by quoting the pressure, volume, temperature, amount. Okay. So this is the answer here. The volume of gas is reduced to half from its original volume. The specific heat will be, see, the specific heat is independent of the volume. Okay, that is given in the page 10. Okay, so the specific heat is independent of the volume. Look at this equation. So the specific heat C is independent of the volume. Okay, so the option 3 is equal to remains constant, so it is independent of the volume. Okay. During the complete combustion of 1 mole of butane, this much kilojoules of heat is released. Okay, the thermochemical reaction of the above changes. See, now the heat is released. That is a exothermic. That is a negative. Okay, then it is 1 mole. Okay, see, now only two options are negative here. This and this. Okay, for this number and this are negative. But among these two options, this is the 1 mole. Here 2 moles are used. So this option is correct. Option 3. Okay. This is formation of the CH4. Okay, at certain temperature, this is the internal energy. Certain temperature is kilojoules per mole. The value of the enthalpy formation is, okay, enthalpy formation. Question number 6. See, this is the equation. Okay, this is the uh, chemical equation for the formation of the CH4, and we have this delta H equal to delta U plus delta Ng RT. Delta Ng is the number of moles of the product minus reactant. So the product there is only 1 mole, but the reactant in the gaseous state actually. So here 2 moles in the gaseous state, here 1 mole. 1 minus 2 minus 1, that is delta Ng is minus 1. So delta H equal to delta U, here minus 1. Your delta Ng substitute minus 1, then this is the equation. So we can write like this. So delta, when RT goes this side. Okay, this is, so now we, from this thing we can conclude that delta H is less than delta U. See, if you write phi equal to 3 plus 2 means phi is greater than 3. So that's how is written here. Okay, so here from this equation the delta U is greater than the delta H. So that is delta H is less than delta U. So delta H is less than delta U. This option 3 is correct. And 5. Okay, this is product minus reaction, and this is that reaction. Okay, in an adiabatic process, no transfer of heat takes place between the system and the surrounding. Choose the correct option for the free expansion. So this is free expansion. That is, work done is zero of an ideal gas under adiabatic conditions from the following. Okay. Notebook. I will show you question number 7. See, delta U internal energy change is equal to heat plus work. For adiabatic process, the heat is zero. For free expansion means work done also is zero. So delta equal to 0 plus 0, 0. So the internal change is zero. When internal energy change zero means delta is T also zero. Okay. Okay, so Q equal to 0, delta T 0, and work done is also 0. So this is given in the book page 3 and 5. Isolated system. Okay. Adiabatic process. There is no transfer of heat between the system and the surrounding. Okay. So this is for the adiabatic process. See, this is the equation. Internal energy change is equal to heat plus work. The pressure volume work for an ideal gas can be calculated by using the expression. Okay, the work can also be calculated from the VV plot, pressure volume plot, by using the area under the curve within the specified limit. When an ideal gas is compressed reversibly and irreversibly from volume initial to final, choose the correct option. So here this is work done for the reversible is less than the work done for the irreversible. That is 6. Work done for a reversible process slowly. Okay. This is the okay, for the work done for the irreversible is more than the work done for the reversible. Okay, for the 8. Okay, so 8, this is the irreversible and this is reversible process. The entropy change can be calculated by using, okay, delta S Q reverse by T. When water freezes in a glass beaker, choose the correct statement amongst the following. Okay. Now, okay, option 9. Justification. Freezing is a exothermic process. Heat released increases the entropy of the surrounding. Okay. So this is the uh, answer. Justification for the answer. Freezing is an exothermic process. Heat released increases the entropy of the surrounding. Okay. So now here you see entropy system decreases but entropy surrounding remains the same. That is wrong. Delta is decrease increases but delta S decreases. This is the correct answer. This system decreases and surrounding increases. Okay, delta S decreases but also decreases. No, this is not the correct answer. So this is 24. So the entropy change, okay, this is the equation for the entropy change. After freezing, look at this, these molecules attain a ordered state and therefore the entropy decreases. Okay, see here, this is the explanation. 10. On the basis of thermochemical equations A, B, and C, find out which of the algebraic relationships given in the options is correct. Okay, this is using the HESS law. HESS law. Okay, question number 10. See, now they have given these equations. So I have written these three equations. Now I am adding this. So this much energy X, Y, Z released in these reactions. Now I adding these two equations. Okay, second and third. Now on the left side we have C graphite half mole of the oxygen. Then here CO, then half mole of oxygen. On the right side we have CO and then CO2. Okay. Now this left side and right side of the same element is the compound is there, then it will cancel out. So now we have on the left side C graphite plus half mole of oxygen, half mole of oxygen. That is, it will become 1 mole here. On the right side, you give CO2 remain. Okay. So now this option is this first equation is equal to the second equation plus the third equation as per the Hess law. So x equal to y plus z. This is Hess law as per Hess law. Okay, so this option is the correct one. Consider the reactions given below. On the basis of this reaction, find out which of the algebraic relations given in the options 1 to 4 is correct. So here the more energy is released in this first X will have more energy released. Here because there is no bond breaking here, but here there is a bond breaking and it will absorb energy, so release energy is less here. The enthalpies of the elements in their standard states are taken as 0. The enthalpy formation of a compound may be positive or negative. So here if you look at the book, see here this enthalpy of various compound formation given below. Some of them positive, some of them negative. Okay, based on this you can say that this may be positive or negative. Okay. Enthalpy of sublimation. Sublimation is solid to liquid and liquid to vapor. That is solid to gases. So in between there are two more stages involved. Enthalpy of sublimation of a substance is equal to enthalpy of fusion plus enthalpy of vaporization. So these answers are wrong. So there are two steps between solid to gas. Which of the following is not correct? You will see is not correct. Okay. Delta G is 0 for reversible reaction. Delta G is positive for spontaneous reaction. So this is wrong. Delta G is negative for the, this is correct. Delta G is positive for non-positive, this is also correct. So okay, now question number 14. See here, this is the equation delta G equal to delta H minus T delta S. Delta G is negative for the spontaneous reaction. Delta G equal to 0 for a equilibrium state. Delta G is positive for the non-spontaneous reactions. Okay. In the following question, two or more options may be correct. Thermodynamics is mainly deals with interrelation of various forms of energy and the transformation from one form to another. Okay, this is correct. Energy changes in the process which depends only on the initial and final state of the macros. This is not correct. How and what rate? So it is not dealing with the rate. So the system in equilibrium state are moving from one equilibrium to another. The equilibrium is also covered. Okay, this 1 and 4 is the correct option. In an exothermic reaction, heat is evolved, that is released. System loses heat to the surrounding. For such a system, this heat will be negative, okay, because released to the surrounding. So that is Q is negative. Okay, this will also be negative. That is enthalpy. Reaction enthalpy also will be negative. 23. Okay. Reaction coordinate. So here enthalpy diagram for the exothermic reactions. Okay. So this is exothermic. Okay. Delta R will be negative. Okay, this is correct, and this also option also not is correct. The spontaneity means having the potential to proceed without assistance of external agency. Okay, spontaneity without assistance of the external agency. The process which occurs spontaneously are flow of heat from the colder to warmer, but wrong gas in a container containing into the contracting to the corner. No, so that is not spontaneous. Gas expanding to fill the available volume. This is spontaneous without external agency. Burning carbon in oxygen to give carbon dioxide. Okay, these two are the options are the correct one. For an ideal gas, the work of a reversible expansion under isothermal condition can be calculated. Okay, for isothermal, this is for the reversible expansion of the isothermal process. So is for this equation. A sample containing 1 mole of ideal gas is expanded isothermally reversibly to 10 times of the original volume in two separate experiments. The expansion carried out at 300 Kelvin and 600 Kelvin. Choose the correct option. Work done at 600 Kelvin is 20 times. No. Work done at 300. Okay, look at this equation and see. Okay, work done at the 600 is twice the work done at the 300. Okay, it is directly proportional to the temperature. Okay, that is correct. Delta is 0 in both the cases. Okay, that is also correct. Consider the following reaction between zinc and oxygen and choose the correct options out of the following options. So, 2 moles of zinc and 1 mole of oxygen, 2 moles of zinc oxide. The enthalpy of the, see here we have to enthalpy change, we have to separate product minus reactant. So here 2 moles of the ZNO. So because this is a negative, delta H is negative, and this should be less than this. Okay, because product minus reaction. So when this is less than the total enthalpy of the, okay, this is correct. Enthalpy of 2 moles is more than the, no, this is not correct because here we have a negative. Whatever the 0.8 kilo energy is evolved, that is released. Okay, because a negative sign, so this is released. These two options are the correct one. Okay. Okay, short answer type. 18 gram of water completely vaporizes at 100 degrees Celsius and 1 bar pressure. The enthalpy change in the process is 40.78 kilojoules per mole. What will be the enthalpy change for vaporizing 2 moles of water under the same conditions? Okay. What is the standard enthalpy of the evaporation of water? See, they are given for 18 gram. 18 gram is equal to 1 mole of water. They are asking for the 2 mole. Okay, 2 mole. 2 into 40.79, that is 81.58 kilojoules. The book also, in this page they have given the similar type of question. 1 mole of a stone requires less heat to vaporize than the 1 mole of water. Which of the two liquids have higher enthalpy of vaporization? Water has the higher enthalpy because it has the hydrogen bonds. Water has the higher enthalpy. Standard molar enthalpy of formation is just a special case of the enthalpy of the reaction. Reaction enthalpy is a special case of formation enthalpy. Is delta reaction enthalpy for the follow reaction same as the formation enthalpy? Give the reason. So the reaction enthalpy is equal to formation enthalpy only if the compound is formed from its constituent elements. So here it is not for CaCO3 is not formed from its constituent element. So here the reaction enthalpy is not equal to formation enthalpy. Since CaC3 has been formed from other compounds and not from its constituent compounds, so these two are not equal. 23. The value of the enthalpy for NH3 is given this. Calculate the enthalpy change. So they actually reverse the reaction. So the formation reaction they reverse it and asking the enthalpy change. So we have to simply change the sign of this enthalpy. It is as per the HESS law. Simply change the sign. Okay, 60. See here, when a chemical reaction, a chemical equation is reversed, the value of this enthalpy also reversed, reaction enthalpy also reversed. So we have to simply reverse this sign, 23. See here, a positive sign. Enthalpy is an extensive property. In general, enthalpy of the overall reaction A to B along one route is represents the enthalpy of the intermediate reactions leading to the product B. What will be? So we have to simply add the enthalpy of the intermediate reactions. Okay, 17. See here, we have to we are simply adding the enthalpy of the intermediate reactions. The enthalpy of atomization of the reaction they are given for the CH4. What is the bond energy of CSC? There are 4 CH points. They are asking what is the bond energy of one CH bond. Then we have to divide by 4. 25. Ca divided by 4, we get this many kilojoules per mole. Use the following data and calculate the lattice enthalpy. See, this is given in the book for NaCl and we have to do for NaBr. Okay. 20. Lattice enthalpy they given how to compute the for the NaCl and we have to do it for NaBr. Okay. So we'll show you how we did for NaBr. 26. See here from sodium solid to sodium gas, this is sublimation enthalpy and this is the ionization enthalpy and this is the bond enthalpy. So here we have to note down, here only half mole we are using. So we have to divide by that bond enthalpy by 2. Okay. Now formation enthalpy is a sublimation plus bond plus ionization enthalpy plus electron gain enthalpy plus lattice. So we have to find out this lattice enthalpy. So lattice enthalpy equal to, see, you take these parameters in the other side. So we get this equation after putting all the values here to minus 735.5. Okay. Given that this enthalpy change is zero for mixing two gases, explain whether the diffusion of these gases into each other is a closed container is spontaneous or not. Spontaneous means delta G should be negative. It is a spontaneous process. Although the enthalpy change is zero, but the randomness or the disorder increases delta S. So therefore in this equation delta G, when you increase delta S, then delta G will become negative. So this is spontaneous. This is the equation. So here when delta S is increases, then delta G will become negative. So that is spontaneous. Heat has randomizing influence on the system, and temperature is the measure of the average radiating volume of the body. Write the mathematical relation which relates these three parameters. 24. So this is the equation. Okay, entropy and the heat and temperature. Increase in enthalpy of the surrounding is equal to the decrease in enthalpy of the system. Will the temperature of the system and surrounding will be same when they are in the thermal equilibrium? Yes, when they are in thermal equilibrium, this surrounding and system temperature will be same. Okay, 26. If the system is in thermal equilibrium with the surrounding, then the temperature of the surrounding is same as that of the system. Okay, at 298 K, this equilibrium constant for the reaction is there given. Predict whether this reaction is spontaneous or not. So we have to use this formula RTL and K, the equilibrium constant. So here 30. So they are using this formula. This reaction is spontaneous. Delta G is negative because Kp is not 1. When Kp is 1, then it will become 0. But Kp is not 1. Delta G is negative. So this is the equation. A sample of 1 mole of monatomic ideal gas is taken through the cycle process of expansion and compression as shown in figure. What will be the delta H of this cycle? Only whole. Delta H of cycle is 0. Okay, that is also given 20. Sum of enthalpy changes around a cycle is 0. Okay. The standard molar enthalpy of the water liquid is this. Will the standard molar enthalpy of the solid be more or less? Okay, so there will be less disorder in the solid. It will be less because ice is more order, that is entropy is less than the liquid. Okay, ice is more order than in the liquid. See 24. See here, for a given substance, the crystalline solid state is the state of lowest entropy, that is more ordered than the gaseous state, that is the highest entropy, that is the more disordered here. Identify the state function and path functions. See, the heat and work are path functions, the other are the state functions. That is also even here in this book speech. So here they have given, see, Q and W are the path function, the other things, these entropy, enthalpy, they are state functions. The molar enthalpy of the vaporization of the stone is less than the water. Why? Because of the hydrogen bonding. Okay. 34. Because of the strong hydrogen bonding in water, the enthalpy of vaporization is more. 13. The magnitude of the enthalpy change depends on the strength of the intermolecular interactions in the substance undergoing the phase transformation. For example, the strong hydrogen bond between the water molecules hold them tightly in liquid space. Okay. Water. Which quantity out of this reaction enthalpy will be zero? Delta G will be zero at the equilibrium. Delta G will be always zero at equilibrium, but the standard delta G is zero when K equal to 1, because in this formula if you substitute K equal to 1, then ln of 1 is 0. But for other values, other values of K, there will be some delta G, non-zero. Delta G will be non-zero for other values of K. 27. So this is that formula, what L and K. Predict the change in internal energy for an isolated system at constant volume. At a constant volume. For an isolated system, there is no transfer of energy as heat or as work. So no work or energy transfer. So delta change in internal energy Q plus W 0 plus so delta U is 0. That is change in internal energy is 0. Continue. Okay. Constant. For the isolated system, this value of the thing will be 0. W equal to 0. Isolated system, delta E equal to 0. Okay. Okay. Question number 37. Although heat is a path function, but heat is absorbed by the system under certain specific condition is independent of the path. What are those conditions? 37. See, this condition at constant volume, where the heat is equal to the change in internal energy. Okay. At constant pressure, it is equal to the change in enthalpy. So, at constant volume and at constant pressure, heat change is a state function because it is equal to the change in internal energy and change in enthalpy respectively. which are all state functions. This enthalpy and the internal energy are the state functions. The expansion of a gas in vacuum is called the free expansion, that is work done is zero. Calculate the work done and change in internal energy when 1 liter of the ideal gas expands isothermally, that means at constant temperature, into a vacuum until its volume becomes 5 liters, 38. So V external volume final minus initial. So because this free expansion, this pressure is zero. So Q equal to zero, then it will be this internal energy change will be zero. Heat capacity is an extensive property, but a specific heat is an intensive property. What will be the relation between the this heat capacity and specific heat for 1 mole of water? 1 mole of water. See, for 1 mole of water, this is 1 mole of water is 18 gram. H2O, 2 hydrogen atoms, 2 into 1. 1 oxygen atom, 1 into 16, that is atomic weight you have to use. So this is the heat capacity. The difference between this CPC can be derived using the empirical relation. Calculate the difference between this, say 10 moles of the ideal gas, 40. This is the equation, so 10 into 4.12, that is the answer, okay, 40. Book page 10. And this is the formula. If the combustion of 1 gram of graphite produces 20.7 kilojoule of heat, what will be the molar enthalpy change? Molar enthalpy give the change. See the significance of the number also. Molar enthalpy change of the carbon. It is graphite 41. Molar enthalpy change of graphite equal to enthalpy change for 1 gram of carbon into the molar mass. Molar mass is atomic weight. That is molar mass is 12 gram. Carbon atomic weight is 12. So in terms of molar it is 12 gram. And this is the enthalpy change. Negative value of the delta is the exothermic reaction. The net enthalpy change of a reaction is the amount of energy required to break all the bonds in the reactant molecules minus the amount of energy required to form all the bonds in the product molecules. What will be the enthalpy change of the following reaction? So they are asking for the reaction enthalpy. Okay. So they have given this bond energy of these things. Okay. 42. See, the reaction enthalpy is bond energy of hydrogen, bromine plus the minus the bond energy of this is the product. Okay, so this is the net bond energy, the enthalpy 42. Okay, page 9. Okay, the bond enthalpy of the reactants minus products in the gaseous state. Enthalpy of vaporization of CCable, this is polyatomic molecule. Calculate the heat required for the evaporation of the this many grams of this at constant pressure. This molar is given molar mass 43. simply divided by the molar mass. Okay, heat required for the operation of the 284 grams is we are dividing by the molar mass. Okay, this is the um, 56.2 kilojoules. Enthalpy of the reaction is given. What will be the standard enthalpy of the formation of the liquid? Okay, they are asking the standard enthalpy. Standard enthalpy means for the 1 mole. Okay, this is for the 2 moles. They are asking for the 1 mole. So 44. According to the definition of the standard enthalpy formation, the enthalpy change for the following reaction will be the standard enthalpy of the formation. So this is the here this 1 mole of the water. Or the standard enthalpy of formation will be half of the enthalpy of the given because given is for the 2 mole. So we are dividing by 2. What will be the work done on an ideal gas enclosed in a cylinder when it is compressed by a constant external pressure in a single step? That is important. In single step, first one will be CS point 2. Explain yeah, 45. Work done on ideal gas can be calculated from the pressure volume graph as shown in here. Work done is equal to this is the area under this AB. This is also given in the book. This is for this single step. 5. See, area under this curve, this is the work done. How will you calculate the work done on an ideal gas in a compression when the change in pressure is carried out in infinite steps? Infinite steps. Okay, 46. Work done can be calculated with the help of the pressure volume PV plot. PV plot of the work of the compression which is carried out by change in pressure in infinite step. Okay, infinite step is shown in the figure. Shaded here represent work done on the case. So importantly, this is for the infinite steps. 46. 6. See, this is for the infinite steps. This area under this curve. Represent the potential energy enthalpy change in the following processes graphically. Throwing a stone from the ground to the roof, and this is a reaction. So the negative sign indicates that is heat is released. Okay, in which process the potential enthalpy change is contributing to the factor to the spontaneity. 47. See here they are given how a stone is starting point of the stone, then point to which stone is reached when you throw. Okay, and this is for the reactant products and reaction coordinates. Enthalpy change in the process enthalpy diagram for a particular reaction is given in here. Is it possible to divide spontaneity of a reaction from the given diagram? No. Enthalpy is one of the contributing factor in deciding spontaneity. That is delta G equal to delta H minus T delta S. It's not the only factor, so one must look for the contributing by the other factor. Entropy also, that is delta S for getting the correct results. See here, There is a entropy, not only enthalpy, but this entropy also is a contributing factor. 1 mole of monoatomic ideal gas is expanded from state 1 to state 2 as shown here. Calculate the work done for the expansion of gate from state 1 to state 2, 290 degree Kelvin. Okay, work done. It is clear from the process that is carried out in the infinite steps from the graph. Okay, hence for the isothermal process, and this is the formula work done. Okay, and calculate, and this is the answer 7. Okay, this is the formula we are using. Okay, ln log. Ideal gas is allowed to expand against the constant pressure. To go from 10 liter to 50 liter in one step. Okay, single step. Calculate the amount of work done in the gas if the same action is carried out reversibly when the work done is higher or lower. Okay. The negative sign shows, so this is the AP external into final volume minus initial volume, and this is the work done. The negative sign shows that the system on the surrounding. Okay, work is done by the system on the surrounding. The work done will be more in the reversible expansion because the internal pressure and external pressure are almost same at every step. 7. Okay, this is the one. Okay, reaction of final minus initial. Okay, final minus initial. Okay, okay. Matching type. Match the following. Adiabatic process means there is no transfer of heat. Okay, no transfer of heat. Isolated system. No exchange of energy and the matter. That is the isolated system. Isothermal means it is a constant temperature. Okay, this is the answer. Fourth function. Heat is a fourth function. And the state function. Internal energy is a state function. Entropy is a state function. Pressure is a state function. Delta internal energy change equal to the heat at constant volume. Internal energy change is equal to the heat. Law of conservation of energy. First law of thermodynamics. Reversible process. Infinitely slow process which proceed through the series of equilibrium states. Free expansion. That is pressure is 0. Free expansion. Delta H equal to Q. Delta H equal to Q at constant temperature. Okay. Intensive property. ALM. Intensive property. Heat is a intensive property. Pressure and specific heat. Extensive property. Entropy is a extensive property. Internal energy is also extensive property. Match the following processes with the entropy change. Liquid vaporizes, that means entropy increases. So it's a positive, entropy change is positive. Reaction is non-spontaneous at all temperature and delta H is positive. So delta S is negative. Okay. Reversible expansion of an ideal gas. Delta change in entropy is zero. Match the following parameters with the description for the spontaneity. Okay. One is C, non-spontaneous at all temperatures. So this is also given in the book. 2A, non-spontaneous at high temperature. 3 is spontaneous at all temperatures. 27. See, from this table they are given. Okay. Match the following. Entropy of the evaporation is always positive because entropy will increase. And D. And this is the formula. K for spontaneous process is always positive. That is RT ln K. Delta G equal RT ln K from that formula. I think. Crystalline solid state. Lowest entropy. Solid state will have lowest entropy. That is more ordered. Delta U in adiabatic expansion of an ideal gas decreases. Okay, combustion of all organic compounds in an exothermic reaction. Combustion of all organic is an exothermic. Exothermic heat is released. The enthalpies of all elements in the standard state are zero. This is nothing to do with that. Both A and R are true, but R is not the correct explanation of the A. Okay, so it is nothing to do with these statements. Spontaneous process is an irreversible process and may be reversed by some external agents. Both A and R true, but R is not the correct explanation of the A. A liquid crystallizes into the solid and is accompanied by decrease in entropy. Okay, solid will have the less entropy. Both A and R true, and R is the correct explanation of the A. Long answer type. Derive the relationship between the enthalpy and the internal energy for the ideal gas and explain the term involved in the equation. Okay, enthalpy and internal energy change. Enthalpy, internal energy change. This is delta Ng is refers to the number of moles of the gaseous products minus number of moles of the gaseous reactants. Extensive property depends on the quantity of the matter. Extensive property depends on the quantity of the matter, but intensive properties do not depend on the quantity of the matter. Explain whether the following properties are extensive or intensive. Mass extensive property, internal energy extensive, pressure intensive, heat extensive, molar heat capacity intensive, density intensive property, mole fraction intensive, specific heat also intensive, temperature and molarity also intensive. 59. So when extensive divided by extensive will become intensive. Okay, mole fraction is intensive. Then moles and total number of moles, these are all extensive property. The lattice enthalpy of an ionic compound is the enthalpy when 1 mole of ionic compound present in the gaseous state dissociates into the ions. It is impossible to determine directly the experiment. Suggest and explain the indirect method measurement of the enthalpy NaCl that is given in the book, and I also explained for the NaBr. So this answer is also given. Okay, this is NaCl for lattice enthalpy, and we can see refer to the book, and also I also given for Na1, and this is the answer. Okay. Delta G is the net energy available to do useful work and is thus the measure of the energy, measure of the free energy, gives free energy. So mathematically that delta G is measure of the free energy. Find the unit of the delta G. If the reaction has a positive enthalpy change and positive enthalpy, yes, positive enthalpy change and positive enthalpy change under what conditions will the reaction is spontaneous. Spontaneous delta G is negative means spontaneous. Okay. For spontaneous, okay, this entropy is greater than 0. Minus delta G is unit of delta G is in joules. Reaction will be spontaneous at high temperatures. Graphically show the work done in an expansion when the state of an ideal gas change reversibly and isothermally from the pressure volume to this pressure volume with the help of the PV plot. Compare the work done, the effort that carried out against the constant external pressure. This is also given in the book, so you can refer to the answer and as well as in the book. This is the reversible work done. This the combined area of this and this work done against the constant pressure is represented by this area. Okay, work done one is greater than the work done two. Okay, so everything is given in the book. You have to apply this fundamental to solve any problems. Okay.